Hello, grade 8. How are you? I hope you're well. Today we will study about colors, more on colors, and we will see how can we present a conclusion. So we studied before about colors, and we said color of light made of three primary colors, which are red, blue, and green. And also we have secondary color that we can combine the primary colors to get these secondary colors like yellow, cyan, and magenta. We cannot make these primary colors, that's why we call them primary colors. We studied also about filters, and we said filters absorb some colors of light and transmit other colors. So they can pass some colors of light and they can prevent the others, they can absorb them. So this is a filter. Today we will study more and more about colors. So look at this picture here. We have different colors of dresses and different colors of outfits. So have you ever wondered what make us see them in different colors? Just the dye that they have, or the colors they have, or something that we can see? And why we can see like more and more of these colors? Like sometimes we have like different kinds of blue, different types of blue. We have dark blue, we have cyan, we have green blue, and we have different kinds of blue. Also, look at the picture here. We said the white color, the white light made of different colors, which is the rainbow color. But this white light, when hit the shirt or the short or any kind of clothes, this piece of cloth can act like a filter. It can absorb all the color and transmit only red, because it's red, so it will work like a red filter. So that's why we can see it red. And also this short is cyan, so it will absorb green, all the colors, and transmit green and blue. So in this case we can see cyan out. Markets sell fabrics of many different colors. Imagine that you are looking at a fabric that looks green. If the light from the sun is mixture of colors, why does only green light enters your eye? So we can look at the markets, we can look at different colors. So why we only see a fabric look green, or something yellow and another thing red? So why we don't see like white, only white, or all the colors in the same fabric? Colored objects absorb some colors of light and reflect other colors. So it works like a filter. So we said filter can absorb some light and colors of light and transmit other lights. But here, these fabrics can absorb some colors and reflect other colors. The red shirt is absorbing all the colors and in white light except red. The red light is reflected into our eyes and we see a red shirt. So this is the reason. We only can see the reflected color. So with any kind of fabric, colored fabric, this fabric can absorb all the colors and reflect only the color that it has. So that color can reflect in our eyes and then we can see it. An object looks white because all the colors of light are reflected. So that's why we can see it white. All the colors are reflected. Okay, what about the black? So here the white light is reflected from this fabric, so that's why we can see it white. What about this black? This black will absorb all the colors inside it, so none of these colors are reflected, so that's why we can see it black. In science, the primary colors of light are red, green, and blue. The colors of light are added together to give all the other colors. So we can mix these primary colors of light and we can get other colors. So, but in art, the primary colors of paint are red, yellow, and blue, not red, green, and blue. This is in art, red, yellow, and blue. The different colors of paint absorb different colors of light. Green paint absorbs all the colors except green, which it reflects. It acts like a filter and subtract the other colors. So here, the green paint can absorb all the colors except the green color. It can reflect the green color, so it subtracts the green color, so that's why we can see it as green paint. If you mix all the colors of light together, you get white light. But if you mix all the colors of paint together, the paint looks black. So here, these are the colors of the paint: blue, yellow, and red. If we mix them together, we will get black. But if we mixed red, blue, and green, we will get white light. Now let's go to the next page and see colored objects in colored light. Filza and Aru are using filters to produce light beams of different colors. Aru shines a colored light on piece of fabric of different colors. Here are her data. So they are using filters to produce different colored light or different colored beam. So they have to take different colored fabric and shine this colored beam on it and see the result. So they have here red light. They produce this red light using a red filter. They shone this red light on red fabric. In this case, they got red. But when they shone this red light on blue fabric, they got black. Green fabric, they got black. Why is this? Because we said red light can pass through red fabric, because red fabric can only reflect the red light or the red color, not the other colors. Blue light in red fabric, they got black. They got blue in blue fabric. They got black in green fabric. Green light, they got black in red, black in blue, and green in green. So in this case, these are their results or their data, and they need to make a conclusion. So her conclusion is, look at my result. My conclusion is a red fabric will only look red in white light or red light. Otherwise, it will look black. It's the same for green and blue. And the other girl conclusion, I don't think that we have enough data to say that there are lots of other colors of fabric and colors of light. Let's find some more data. They need to do another investigation to make sure that their conclusion is correct. So, Filza does the same research on different colored objects in different colored lights. Here are her data. Red light. On red object, they got red. On blue object, they got black, and on green object, they got black. Blue light. On red object, they got black. Blue object, blue. Green object, black. Green light. They got black on red, black on blue, green on green. Yellow light. Okay, now they added these secondary color. Yellow light, they got red on red, black on blue, and green on green. Cyan light, they got black on red, blue on blue, green on green. And magenta light, they got red on red, blue on blue, in blue, and black on black. So why here they saw red, green, and they got black and blue? Because we said yellow light is mixture of red and green color, and we said cyan color is a mixture of blue and green. We said about the magenta is a mixture of red and blue. So they can reflect these two combined colors and they can absorb the other one. So here her conclusion said, some of the new data do support my conclusion, but some don't. Is there a better conclusion? Filza writes this conclusion down. Colored objects reflect the colors that they are. If the light shining on the object contains one or more of these colors than that of the color that you see, then that is the color you see. So here, if the object contains red and blue color, then we can see magenta. If the cyan object has blue and green inside it, then we can see cyan. If the light shining on the object doesn't contain any of those colors, then it will look black, like here. Green color is not included here in the magenta light. Magenta light composed of red and blue only, not green. That's why in green object she saw it as black. This is the case for both primary and secondary colors. So when you do an investigation and write your conclusion, you need to make sure that it takes into account all of the data. You should also make sure that you write a conclusion that your data support. So in our projects, we should support our data by a conclusion or conclusion that support the data. So if our data is correct, that means the conclusion should be correct. If we got another conclusion, that means the data are not reliable to use them. So we need to have more data, we need to have more investigations and repeat the test more than one time. So now let's go to the summary of the lesson. Presenting conclusions more on colors. A colored object absorbs all the colors of light except the color that it appears to be. So like the red fabric, so it will absorb all the colors except the red one. And colored objects appear different colors in different colored light because they absorb certain colors and reflect others. So like the different objects, different colored objects, like any for example red object, it can appear red and reflect red color but absorb all the other colors in the light. When you write a conclusion, you have to make sure that your data support it. And don't forget that colored objects act like filters. Why do they act like filters? Sometimes I will ask you, this is a good question, why colored objects act like filters? Because we can say, because colored object can absorb all the colors of light and accept the color that it appears to be. So this is all about presenting colors, more on colors. I hope you understood the lesson. Don't forget the homework, the yellow box, and if you have any question, write it down and I will check it. Stay safe and see you soon. Bye bye.